Section 1.2, Points, Lines, and Planes. And it's really like my favorite day because it's our first day of geometry. Okay, so in geometry we're going to be learning lots of definitions, lots of things called theorems and postulates, which we'll get to later. But a definition uses known words to describe a new word. Well, in geometry, some words, such as point, line, and plane, are undefined terms, meaning I have to tell you, we have to come up with an agreed upon name definition for them, so that we can define other things using them. Okay, so what we have to do is we have to actually agree on their definitions.
Hi, so now I'm going to try and define these three undefined terms for you. So a point is just a place, you know a point, if I draw something like that, that's something that we describe as a point. We have to make sure that we understand, though, in the big picture, points have no size. They have no size. We normally, in geometry, are going to indicate a point with a capital letter, such as A, and every figure we have is going to consist of points, okay? So all figures consist of points. Consist of points. So like this figure over here to right, it's made up of a bunch of points, some that we don't have names for, but like look, there's points all the way around here, and even where we don't see them, but I drew this cube to kind of give you an idea, okay? A line is something that extends in two directions and never stops. So although in this cube I've actually drawn line segments, a line would actually go on forever. You're used to drawing lines in the coordinate plane, and we always put arrows on the end of lines. All right, when we're describing a line for geometry, we're going to use two capital letters, and we're going to put the line symbol above it, like that. Okay, we might also use something like this, write it as line A. Like a small capital letter, and we would write it as line A. Okay, plane's actually usually the hardest one for kids to understand. A plane is a flat surface that extends infinitely. In both directions. So back when they didn't know that the earth was round, they thought it was flat, and they thought it would keep going on and on and on forever. Well, this picture actually is trying to show you, like, this would be a plane, but it would keep going on and on. So this is actually a finite picture, but a plane would go on infinitely. All right, so we usually name planes with, in your book, they usually name planes with 4 letters. So if I were talking about this plane right here, I would name it A, B, C, D, 4 letters. Or if I was looking at this plane over here, I could name it, I could call it D, C, G, H. Okay, sometimes I might say plane C. And we're going to talk about that more in class. But for now, I just want you to understand it to be something that's a flat surface that extends infinitely. All right, these 3 then allow us to define some of the things that we defined this week in class, okay? So collinear points. Collinear points are points all in one line. Points all in one line. I'm going to show you examples of each in a second. So let's just get the definitions written, then we'll go over them. Coplanar points are points all in one plane. Okay. A line segment we defined this week. I'm going to do it again. It's a piece of a line. So in that picture I showed you, I was actually showing you a line segment. So if I was talking about I had this line AB, and I just wanted to describe for you this piece of it, this segment, we would call that AB. We take both of the endpoints and we would just put the segment symbol above it, okay? All right, array we talked about. This week we were doing inequalities, and we said, okay, x is greater than 2, and we drew a number line and we put a 2 on it and we put an open circle and we went like that, that's actually, we described it as a ray. So a ray is, again, a piece of a line that starts at one point and goes infinitely in one direction. Okay, so I'm going to use this as an example as well. So here, if I wanted to describe, how about I call it C-A-T. Okay, so if I wanted to describe the ray that has endpoint C, I would take C, and I'm going in the other direction, so towards A or towards T, I could call that ray CA. So it would start here and go here forever. I could also call that CT. The most important point is that the endpoint goes first when you list them. Okay. Now, if I wanted a ray going this way, like from T towards C, I'd still do T, C, and the ray symbol would always go to the right. So ray's symbols will always go to the right, regardless of the direction that the ray is going. All right, this one's important. Big, listen up. Take a pause. Opposite rays. Opposite rays start at the same endpoint. And go in opposite directions. Go in opposite directions. So A, B, C. Okay, if I wanted to start at the same endpoint, I'm going to start at B. Ooh, let me not use blue, let me use red. So BA, ray BA, and ray BC are opposite rays. What I'd like you to understand that is that opposite rays create a line, a straight line, create a line. Now, rays like this are not opposite directions, so those are not opposite rays. Opposite rays will always form a line. Okay, so now let's look at some pictures. So it says, name 3 points that are collinear. So let's remember, collinear points have to be on the same line. So looking at this picture over here to the right, L, M, and N, those are points. Remember, we just used the capital letter. Those are collinear points. You could also say that K, M, comma, and P are collinear points. Again, they're all on the same line. All right, so name 4 points that are not coplanar. Okay, so this rectangle or this parallelogram is actually, we're using it as a plane, okay? So 4 points that are not coplanar might be L, M, R, and K. So L, M, R, and K, not on the same plane. Okay, name 3 points that are not collinear. Okay, so any points that are not on the same line. So maybe like L, M, R, or N, M, P. Those are not collinear because they are not on the same line. Okay, so let's try and draw it. Draw collinear points A, B, and C. Go ahead. Okay, so what I'm thinking you drew is something like this. A, B, and C, okay? Draw a point D that's not collinear to that. So I'm just going to actually draw it above it. I'm going to label it D. It's not on that line, okay? Draw line AB. Okay, so you see those symbols are telling me what to draw. Okay, so I'm going to draw a line. I could put the A here and the B here. It doesn't matter as long as it's a line. There's my line, right? Draw ray BD. Hopefully you're remembering the most important part is that that has to be the end point. So I'm going to draw B, and I'm going to put D on the ray. Okay, segment CD. Remember, segments end. So segment, here's C, here's D, and I'm connecting them. You might remember that as our compound inequality when we graphed the other day and we did like x is greater than 5 but less than 7. We drew a number line. We put a 5. We put a 7. We wanted everything in between them. Okay? Do it like that. That's a line segment. And opposite rays, what did we say? Opposite rays are going to form a straight line. So I'm going to do something like this. So A, B, and C. So ray AC and ray AB are opposite rays. Okay, so that kind of gives you an idea, even though we've been looking at these in class. I want to move on to intersection now. So Now, what do you know about intersection? Well, you're probably used to a road intersecting like in this picture, okay? These two roads are intersecting right here, right? You may also be familiar with graphs that intersect. So here we have a parabola and a line intersecting. In geometry, the intersection of two figures is the set of points that are in both figures, okay? Intersect really means where it meets or cuts through. That's where things intersect. So if I go back to that picture, oops, not that one, this one, these figures intersect at that point and that point because that's where they meet or where they cut through. These two streets, they intersect here, okay? So that's what it means to meet or cut through. Now let's talk about lines, okay? How many places can two lines intersect? All right, so I'm going to draw a line to see. There's a line. Well, I guess the only way I could intersect a line would be here. So two lines, they can only intersect in one point. In one. With one small exception. What if I took a line like that, and I took another line and I put it right on top of each other, right on top of that line? This one we would say intersects everywhere. Intersects in all points. Okay. One thing that can be really hard to see is intersecting planes. So here's what I did. I took a picture of two, I'm going to call these pieces of paper, and I sliced them in half. And what you might notice is that they intersect in this red line right here. Intersect in this red line. Now, these planes again stop. We have to remember that they go on forever. So this is actually a line segment in the picture, but when we think about infinity, we know that this intersection would go on forever as well. So two planes actually intersect in a line. Okay? All right, so right now in your notes, you might see that it says sketching intersections of lines and planes. We're going to do that in class. So if you go to the top of the next page where it says, where do two planes intersect? I want you to two planes intersect in a line. So if I was asking for the intersection of two planes on a test or a quiz, you'd have to give me a line. We'll say A, B, and you'd have to use the symbol, the proper symbol for A and B, okay? All right, what I want to do is talk about this picture right here. Intersection is really, really important. This is a house. It might look like your house, but we have all different kinds of things intersecting here. For example, this is a line right here. If I extend it forever, it intersects with this right here, and it intersects with this right here. Now, what we're looking at is segments, but we can imagine a line going on forever. We can see that this segment and this segment intersect. They intersect right there. We can see that this and this on the stairwell intersect. They intersect right there. So that's what we have to get to a point. We have to get to the point we understand that intersection means where the lines meet, where they cross each other, or where they are equal to each other. All right, guys, I think I'm going to stop there for today. Have a great day. Talk to you later.